In this video, we're going to apply some implicit differentiation to looking at some related rates with supply, demand, and price. We have the demand equation for a certain brand of headphones is given by this 100x squared plus 9p squared equals 3,904. I already like this problem because I'm not seeing any crazy product rules or anything. My equation looks nice and straightforward. 100x squared plus 9p squared equals 3,904. We're taking the derivative with respect to time, so I can even jump in and take my derivative, see what that would be. I'm going to bring down the power, subtract one for the new power. So I'm going to get 100 times 2 is going to give me 200 x dx dt. For that first piece, we took the derivative of x with respect to time. Next one, 9 times 2 is 18. So we're going to get 18p dp dt. And then on the other side, it is not going to be 3,904 anymore because we're going to take the derivative of that, and it's a constant, so the derivative of it will just be 0. But we're also going to have to figure out what numbers were given and where they go. So I'm going to make my little variable cheat sheet off to the side. This equation, 100x squared plus 9p squared, has x's and p's. So I'm going to get an x equals, a p equals, and then their respective derivatives with respect to time. So we're going to have a dx dt and a dp dt. And I'm going to pay attention to what the units say. So all we read was the demand equation for a certain brand of headphones is there, and we were able to do so much of the problem already. Now I'm going to read through where x is given in number of thousands of headphones. So x being 2 wouldn't mean they're only selling 2 headphones. It would mean 2,000. So that's in thousands of headphones. This is going to be in thousands of headphones per whatever the time unit is, maybe weeks, month, or years. Well, it's the number of headphones demanded each week. So this is going to be thousands of headphones per week. And the price is just in regular dollars. So they have their dollars per headphones, and their price is going to be changing in dollars per week. So how fast is the quantity demanded increasing? How fast is the quantity demanded increasing? Do you think that's dx dt as the demand increasing, or dp dt? Well, dp dt means price is increasing. X is the demand in thousands. So we must be finding dx dt. But even if I couldn't find that right off the bat by reading that first sentence, I would still keep going and try to put things where I think they go, and then go from there to figure out which derivative am I solving for the final answer. It says the unit price per headphone is $16. So it's definitely not going to be x or dx dt since this is in dollars. It must be p or dp dt. Is that the current price of the headphones, or is that how fast the headphones are changing each week? Well, it doesn't say the price per headphone is increasing by $16 per week. It just says the current price is 16. So that's going to be the regular p. And the price is dropping at a rate of 10 cents per headphone per week. So that's our rate of change. Careful, it's 10 cents, so it's not going to be 10. This is in dollars, so 10 cents is going to be 0.1. And we're dropping the price, so should our derivative be positive or negative? It should be negative. We have a negative 0.1 for our dp dt. We're decreasing our price by 10 cents per week. How is that going to affect our demand? Is it going to make our demand shoot up? Or if it doesn't, maybe we shouldn't even be dropping the price. If there's not going to be a payoff with more people buying our product, we probably won't drop our price. The other thing I see here, though, is I'm missing x. So I'm solving for dx dt. That's completely normal to be missing a derivative, but we shouldn't also be missing a variable. So I need to figure out what x is, especially because I'm plugging it in here in the equation. So I need to figure out what is the current demand with the price being $16. Again, if you are missing a variable, plug in to original equation. So here we have, to find x, we know 100x squared plus 9p squared. So it's going to be 16 for our p getting squared equals 3,904. So I can grab my calculator, make sure you do PEMDAS, so you do the exponent before you multiply. So 16 squared, then times 9 is going to give me 100x squared plus 2,304 equals 3,904. Now I can subtract this 2,304 from both sides to try to get the x on one side by itself, which gives me 100x squared equals 1,600. Now I'm going to get rid of that multiplication by 100 by dividing both sides by 100. So x squared must be 16. And now I can do the square root of both sides. Remember, when you do square root of a number, you do plus or minus that square root. So x is going to be plus 4 or minus 4. Let's think about what's realistic for this. X is just demand. It's not a rate of change. So it can't be negative. They can't sell a negative number of headphones. Worst they can do is 0. So their demand must currently be 4,000 headphones when the price is $16. And they want to start dropping their price by just a tiny bit and see if there's a big payoff with people buying more of them. There might be a similar product on the market that is sold by another company that's going for a little bit less. That's what's holding their demand back. So if they can get closer to that competitor's price, they might sell a whole lot more than they are right now. So let's see, by plugging into our derivative now, we know everything except for the dxdt that we're trying to solve for. So I'm going to plug in 200 times the x. We just worked hard to figure out that they're at 4,000 for their demand. We don't know what dxdt is. That's okay. We're going to solve for it. Plus 18 times our p. The price right now is $16. That's given in the problem. And it's also given that they're dropping their price by 10 cents. So negative 0.1 for dpdt, which again, if you don't do that side work, setting up your variables and their units, you will probably be plugging in wrong numbers all the time. So 10 cents is really negative 0.1 because p had to be in dollars, not in cents. So I'm going to plug these in. I have 200 times 4, which is going to be 800 dx/dt. And then I have 18 times 16 times negative 0.1, which gives me negative 28.8 equals 0. I'm trying to get dx/dt by itself, so I'm going to add this number over. Add that 28.8 to the other side and get 800 dx/dt equals 28.8, and then we'll just divide both sides by 800. So dx/dt is 28.8 divided by 800, which is 0.036. And again, this setup is going to save me figuring out what this answer even means. We have 0.036 thousand headphones per week, which makes more sense. You don't want to sell 0.036 of a headphone. That doesn't make sense, but it's of 1,000, so we can multiply that out by 1,000, which would tell me that they're selling 36 headphones per week, or how much they're increasing by. So for our conclusion, we're going to say what we were given. As the price drops by 10 cents per week, the demand does what? Is it increasing or decreasing? We got dx/dt is 36. So it's positive. So the demand is increasing by 36 headphones per week. So they can decide if that 10-cent drop is worth it. Just dropping a tiny little 10 cents has them sell 36 more headphones. They're going up from their original 4,000 demand, and then they would decide as a company, do we think it's worth it to drop our price just a little bit to sell a tiny bit more headphones and figure out what's that sweet spot between our price and the demand that we're looking to get.